In today's lesson, our focus will be on the remainder theorem. And the remainder theorem states that, it concludes that if p of x is divided by x minus a, the remainder is always p of a. That is, the value for x that we'll use interchangeably will now become a, which is a constant. Okay, well, let's try this example so that we'll be able to explain better what the remainder theorem concludes. The first example, from the knowledge of looking for the quotient and the remainder, you do the same thing here. We have x raised to the power of 3 plus 5x squared minus 3x plus 1. We are dividing it by x plus 1. Recall that we only used the first, we use x to divide everything here. So we have x cubed divided by x cubed divided by x. 1x will divide, when it goes with one of this, it's remaining x squared. We have is x squared. Now immediately you divide, the next thing you do, you multiply. X squared times x will give you x cubed. Then x squared times 1 will give you plus x squared. You subtract. X cubed minus x cubed 0. 5x squared minus x squared will give you 4x squared. Both of them are plus, so that's plus 4x squared. You bring down the next number you're supposed to use to divide, which is x, 3x. Now we return back to the same thing we did. 4x squared divided by x will give us plus 4x. Now immediately we do divide, multiply. 4x multiplied by 4x. 4x multiplied by x will give us 4x squared. 4x multiplied by 1 will give us plus 4x. We subtract again. So 4x minus 4x 0. So here we have minus 3x minus plus 4x. So we have minus 3x minus 4x. Our answer is minus 7x. So we have minus 7x. You bring down the next number plus 1. Minus 7x divided by x will give us minus 7. Minus 7 times x will give us minus 7x. Minus times plus is minus. Minus 7 times 1 is 7. You subtract again. Minus 7x minus 7x is 0. Then we have 1 minus 7. So we have 1 plus minus times minus plus 7 is equal to 8. So it gives us plus 8. Right, so that's that. Now what this theorem states, to apply it whenever you're asked the question, what this theorem states, it says the remainder theorem concludes that if p of x is divided, if this is divided by this, the remainder, which is p of a, the remainder is now p of a. So let's see if we attach this value. Look at what it means. X plus 1 is equal to 0. Okay, so we have x is equal to minus 1. So anywhere we see x, we input minus 1 to see if our remainder will give us 8. That's what the theorem states. So we have x cubed, which is minus 1 raised to the power of 3, plus 5 minus 1 raised to the power of 2, minus 3 minus 1 plus 1. Minus 1 raised to the power of 3 is minus 1, because minus 1 times minus 1 times minus 1. Minus 1 times minus 1 is 1. 1 times minus 1 is minus 1. Then minus 1 square is 1, times 5 is 5, minus times minus is plus, plus 3, then we have plus 1. This is minus 1 goes with plus 1, so we are left with 5 plus 3, which is equal to 8. You can see that it has proven the theorem. Now the theorem concludes that if P of X is divided by this, then the remainder is P of A. It means that when you input the value of the constant into each of the x's, the answer will give you the remainder. This is always given, maybe when you are giving questions in your as objective, so that you, instead of doing this long method, you can just impute it and get your remainder straightforward, except you are asked to show how you got your working. Then you use division method to find them. Now the same thing let's do for the second exercise. The second exercise is x raised to the power of 4 minus 3 x raised to the power of 3 minus x squared plus 2x plus 1 is divided by x minus 1. X raised to the power of 4 divided by x will give you x raised to the power of 3. X raised to the power of 3 multiplied by that, it give you x raised to the power of 4. Minus 1 times this will give you minus x raised to the power of 3. Subtract. This is 0. Minus 3 minus 1. So we have minus 3 plus 1. So we have minus 2. Okay, so now we have minus 2x raised to the power of 3. We bring down the next number, x squared. We do the same thing again. Minus 2x3 divided by x is minus 2x squared. You can, if you feel confused, you can just bring it out somewhere and then divide it. X will, when you remove one of this, is remaining 2. That's how you get it. Okay, so we have, after that you multiply. Minus 2x squared multiplied by this, minus 2x3. Minus times minus is plus 2x squared. Subtract again. Minus 2x3 minus that's 0. Then we have minus 1 minus plus 2. Minus 1 minus plus 2. So minus 1 minus times plus is minus 3. So we have minus 2. So we have minus 1 minus 2 will give us minus 3x squared. We bring down the next number, plus 2x. Minus 3x squared divided by x give us minus 3x. Multiply it again to give you minus 3x squared. Okay, minus times minus will give us plus 3x. Subtract again. So what we have here is 2 minus plus 3. So we have 2 plus 2 minus times plus is minus 3. So we have minus 1. So what we are left here is minus x. Then you bring down the next number, which is 1. Minus x divided by x is minus 1. Minus 1 times x minus x. Minus times plus, minus times minus is plus. The 1 times 1 is 1. You subtract. So this is 0. 1 minus 1 gives us 0. So it then means that this one has no remainder. If if we are to apply it based on what the theorem states, if they ask you to find the remainder of this one, maybe in your objective, you can as well try it this way. X minus 1 is equal to 0, so that our x is now equal to 1. You input the value of x into each of these polynomial. So we have x raised to the power of 4 minus 3x3 minus x squared plus 2x plus 1. S is 1 raised to the power of 4 minus 3 open bracket 1 raised to the power of 3 minus 1 open bracket raised to the power of 2 plus 2 raised to the power plus 2x x, which is 1, plus 1. S raised to the power 1 raised to the power of 4 is 1, minus 1 raised to the power of 3 is 1, minus 3, 1 raised to the power of 1 here again, of 2 is 1. Then this one is 1, 2 times 1 is 2, plus 1. Let's add up all the positive number. This is the positive number, the positive and positive. So we have 2 plus 1 plus 1. What we have is 4. Minus 1 minus 3. Or minus 3 minus 1 will give us minus 4, which is equal to 0. It then means that if you are asked to find the remainder of this, the remainder of this one is 0 when given the question, and the remainder of this one as well is plus 8. So you can find as much remainders, you can solve it applying it in different questions to give you your value.